Hi everyone, welcome back to Mr. Edmond's channel. This is Jan 2026 P4 walkthrough. Please don't forget to subscribe, like, share the content, leave a message for me if you need more clarification, or let me know what you need me to cover in the next video. Thank you. All right, we got the next question. We got question 5 here. Question 5, we have the parametric graph, and then we have the x. That's the graph given. You have the equation for x and equation for y. And these guys have asked us to find, part A is to find the point P, which lies on the curve C, but the T at that point C is 3. Find the coordinates of point C, point P. Now, it is a parametric graph. That means if you're looking for x, you have to get x from here and then y from here. So our x value, we just substitute in our 3. So it is 4 into 3 minus 5 over 2 into 3 plus 1. And for the y is 2 into 3 squared minus 4 into 3 plus 4. When you press your calculator, you see that our x is equal to, our x is 1 and our y is 10. So that's a point P. So P is a point 110. We move on to part B. In part B, they want us to find the dy dx. We want to find the dy dx here. Now, I've written the x over here. Now, the dy dx, in this case, we're going to use the chain rule. So dy dx will be equal to dy dt multiplied by dt dx, or you have it as dy dt divided by dx what? dx dt, but I prefer using this one over here. So what we do, we are going to find the value of the dy dx dt. So this is our dx dt. We are going to use the quotient rule. This is 4t minus 5, and I have 2t plus 1. So your u is 4t minus 5. So your derivative of u is going to be 4. And your v is 2t plus 1. So your derivative of v is going to be 2. Now get your dx. So the x dt, the derivative of u, which is 4, multiplied by v, which is 2t plus 1, minus the derivative of v, which is 2, multiplied by u, which is 4t minus 5. All of it over 2t plus 1 squared. So your dx dt, you try to simplify this. You have 8t minus 80 minus 8t is going to cancel out. So you just have now 4 times 1, which is 4, minus 10, which is a minus. So this is 14 over 2t plus what? Plus 1 squared. Now we get the dy. Dy dt is the simplest one. It's just a derivative of this quadratic one, which is 4t minus 4. Now it's time for us to join it together. So our dy dx, I'm going to use this formula over here. I'll get dy dt, which is 4t minus 4, and I multiplied by dt dx. I just flip this. dt dx, I'm going to flip that. So I'm going to have 2t plus 1 squared over 14. So that means my answer here is that dy dx, I can divide, I can factor this one before outside here. Then I have t minus 1. Then I have 2t plus 1 squared over 14, because they want us to simplify it. If they didn't ask to simplify it, it will be fine. So that means your final answer would be 2 into t minus 1, 2t plus 1 squared, all of it over what? Over 7. That's my dy dx. All right, that's a dy dx. That's part B. Part C, they're asking us to find the equation of the tangent to C at P, right? The answer y is equal to mx plus c. Now, remember, a tangent is a straight line, so we have it over there. Y is equal to mx plus c. If you find the equation of a straight line, what you want to find first is the gradient m, and you know the gradient m is going to be the dy dx at what? At point P, That means that p, and the dy dx here, we have our dy dx, the derivative, dy dx is equal to this. But what's our point p? Our point p, the t at that point is equal to what? The t at that point is 3. From part A, the t is 3. That means you're substituting 3. So you have 2 into 3 minus 1 into 2 into 3 plus 1 all squared, all of it over 7. When you press your calculator, it turns out to be 28. So the gradient is 28. That means this is your equation is y is equal to 28x plus what? Plus c. Now you know the coordinate of p. This from part A, p is equal to 110, or it shows over here, p is equal to 110. So that means when your y is 10, your x is 1 plus c, then you see that your c is equal to minus 18. So for your equation of the tangent is going to be y equals to 28x minus 18. That's part C. All right, what do you have in part D? Okay, part D, what we have here is saying that given that the Cartesian equation of C, so if we change this into a Cartesian equation, that means y as a function of what? Y as a function of x. F of x is defined for all values of x on C. Defined for all values of x on C. Determine or find the domain of what? Find the domain of C. Now, one thing you have to remember here is that the domain are the x values, and then the range are the y values. That means in order for us to find the domain of the function f of x, we need to find the range of what? The range of x. The range of x will be the domain, and the range of y will be the range. So the range of y will be the range of your function, and the range of x will be the domain. The range of x will be the domain of your function. Okay, so that means in order to find part A, we need this will be the answer for part A, and then this will be the answer for part B. Now, but x is equal to this function here, defined in terms of t, but they say t is greater than 0. Now, what I always do, I always prefer answering these domain and range questions using the graph. If you not use a graphing calculator, you can do it, or you can just do it by just getting a simple sketch. I'll get a simple sketch of this graph and then see how the equation actually looks like. Okay. Now, I'm going to sketch this graph. So this graph, and see what I'm looking at. So this graph here. So this is the t. This is the t. And now what will be the y value now? It's what? Is the x. Now when you see here, t cannot be equal to this one equal to 0. That's minus a half, which is over here. That's minus a half. T is equal to minus. That's minus a half. And then there is the horizontal asymptote. The horizontal asymptote is always this divided by that. So it's divided by 2, which is 2. So t is equal, x is equal to what? X is equal to 2. And then what you get next, you get the y-intercept. The y-intercept, substituting x equal to 0. In this case, t. Substituting t is equal to 0 in your equation. When putting t is equal to 0, you have -5. It means that your curve cuts here at negative what? At -5. Automatically, you know, the curve has to go towards this and also towards that. How can it do that? It can only do that if it's going to cut like that. If it's going to cut like that, that's how you can do it. And then this part of the graph is over there. But remember, they said here that t should be greater than what? T should be greater than or equal to 0. That means the only part of the graph you're looking for is this part of the graph. And when you look at this part of the graph, the values of your x, they only start from -5, and then they go all the way onto that side. That means your x values start from -5 up to 2. They don't go past 2. This is going to be that will be your domain of the function. So remember, I'm trying to look at the graph of the x only. Now, what I'll do for the range, I'll look for the graph of y. The graph, see that this is a quadratic graph. This is a quadratic graph, but still t is greater than what? T is greater than 0. But still, I want to visualize it. When I want to visualize it, t is equal greater than 0, I put t is equal to 0. If I substitute t is equal to 0, I have 4. So that means it cuts here at 4. But I don't have the range of this y value. I don't have the range of the y values. The only way to get the range of the y values is for me to get the nature of the graph. I know it's going to be a U shape, but I don't know whether it is U like this over here or it is U over here. So I need to find the turning points in order for me to see that. I'll try to figure out the turning point of this graph. And you can do so many things to get the turning point of the graph, or you can get the roots of the graph. I prefer to get the turning point of the graph. So let me get the turning point of the graph. What can we do here quickly? You can compute the squares, or you can compute the squares here, or you can remember that you can get the vertex. The vertex is always minus b over 2a. So your vertex is minus b. This is the b we're talking about, which is equal to 4 over what? Over 2 into 2. So it's going to be, but it's a minus, so it is a plus. So it's going to be x is equal to 1. So your vertex is at x is equal to what? X is equal to 1. But remember, this is t, not x. This is t. T is equal to 1. So that means your vertex somewhere over here. It is positive. T is equal to 1. Then you have to get the y. So get t is equal to 1. Substituting t is equal to 1 into the y. That means your y here, and put it t is equal to 1. Substituting t is equal to 1, you end up with y is equal to 2. That means your vertex is at a point 1, 2. So your graph looks like that. That's how your graph looks like. That means your minimum point is actually, your minimum point of the graph is actually equals to 2. 2 is your minimum point of the y. And we don't need this, but even if you don't need that, but you can, your graph actually starts from here and then it goes over that side. By that means the smallest value of y is 2, and then the graph goes on going up. That means your y value is greater than what? Greater than or equal to 2. So your range, or your range of f of x is that f of x is greater or equal to what? Or equal to 2. Like that. It's out of explanation for 3 marks, but I have to explain it. But if you understand it, it doesn't take that much time.